Hello, my name is Diana Kim, and I'm a technical program manager on the Windows Responsible AI team. On behalf of the entire Windows community, welcome to Build. It's no secret that we are in the age of AI, and I'm sure you, much like us, are thinking about all the ways that you can develop with and enable the capabilities that AI has to offer. I'm here today to share how we at Windows develop AI experiences responsibly and give you tools to do the same. Here at Microsoft, we follow our Responsible AI standard, which consists of 6 principles: fairness, reliability and safety, privacy and security, inclusiveness, transparency, and accountability. Fairness refers to what we may traditionally think of as responsible AI. How well and equally does the system perform across all groups of people? Reliability and safety, which refers to how we handle incidents and issues as they may arise. Privacy and security, which refers to how we treat and secure customer data. Inclusiveness, which ensures experiences are usable for all groups of people. Transparency, which ensures customers know how and when they are interacting with AI. And accountability, which refers to using models and AI systems for their intended purposes. All 6 of these principles span both socio-technical and technical considerations, meaning while they can be baked into the code of the experience itself, they may also be included in things like customer transparency documentation or even in the UI of the experience itself. And I want to emphasize that all of these are equally important to creating a holistic and responsible experience. Today, we'll be walking you through many of these considerations and techniques and taking you through some of the cutting-edge tools Windows has to offer. For the purposes of our talk today, we're going to be specifically focused on the Copilot+ PC. The Copilot+ PC is a line of Windows devices which contain an NPU, or neural processing unit. You can think of the NPU is to AI as the GPU is to graphics. The NPU enables on-device inference of models, which gives you great benefits such as reduced latency and enhanced privacy and security. And on top of that, Windows has also put together some powerful developer tools to jumpstart your experimentation and development process. The one we will be specifically focused on today is the Windows Copilot Runtime APIs, available in the Windows App SDK. These APIs enable local AI capabilities such as text generation with 𝗦𝗲𝗀𝗀𝗧𝗏, background segmentation, text extraction, and many more. Okay, so enough of me talking, let's jump in. Here I have my Copilot+ PC with the Snapdragon X chipset. And like I just said, you already know that this device unlocks a whole world of awesomeness with the AI experiences that are baked into it. And it also has those baked-in developer capabilities, which is what I'm going to show you now. So first we're going to take a look at AI Dev Gallery. I already have it downloaded here. But if you have a Copilot+ PC, go ahead and pause and download it from the store and follow along. As you can see from this homepage, AI Dev Gallery contains numerous different samples and tasks that you can accomplish by using on-device AI. All of these have sample code that you can clone into Visual Studio and start working on right away. Okay, I'm going to go ahead and head to the Samples tab on the left, and we're going to end up in the Samples Overview page. There's some other categories over here. Like I said, they have a bunch of different samples and capabilities that you can try out, but for today, we're going to be talking about generative text. Generating text falls into the generative AI category, which carries some unique considerations compared to traditional ML techniques or non-generative models. So I'll click on the generative text section, which will pull up this nice UI for us to play with. As you can see, we have a prompt box, which takes free text, and a dropdown which shows which model we're using. AI Dev Gallery defaults to 𝗦𝗲𝗀𝗀𝗀𝗀𝗀𝗀 which is a small language model baked into Windows Copilot Runtime and is optimized to run on your NPU. There are some other options that you can download and play around with too, but for the sake of today, we're just going to stick with 𝗦𝗲𝗀𝗀𝗀𝗀. Awesome. Now it's time to generate some text. We're going to be gradually stress testing the system, so first I'll start with something that we can all agree on. Let's go with I love puppies. And generate. Awesome. What a great response. I definitely agree with that. Okay, but since this is an RAI demo, we're going to start gradually stress testing the system. I'm going to start with something that I know we don't want the system to respond to. Let's go with the opposite of what we did first, something hopefully we can all still agree on. I'm going to erase this, and we're going to go with I hate puppies and generate. Perfect. That's what we wanted here. The intended behavior is that we don't want the system to engage with this kind of content. Okay, so we're gonna stress test it a little more. Let's pick something a bit more nuanced. There are some situations where it's actually okay for a system to engage with certain content that it may not be okay to engage with in other situations. A classic example we think through in this space is gaming. In certain gaming contexts, it may be okay to allow a little bit more violent content depending on the nature of the game, of course. In terms of a gaming example, I did just see the Minecraft movie, so I think that would kind of be something fun for us to go with. Let's say that I am a user who is not experienced in playing Minecraft, and I want to get some information on how to get rid of mobs. And, for the sake of this demo, let's say the developer who created this app has some reason that they don't want people to know how to get rid of zombies and skeletons and spiders. So, first I'm going to try how to slay mobs in Minecraft. We do get a response for this one, and it is some helpful info, but remember, like we just said, I don't want the system to produce a response here. Thankfully, there is an easy fix for this. There are some developer controls within the Windows Copilot Runtime API that can help us easily mitigate this. I'm going to go ahead now and pull up the Windows Copilot Runtime test app. This code is available on GitHub if you'd like to download it and start playing around. I went ahead and cloned this repo in advance, so I'm just going to go ahead and start running it now. Great. As you can see, it's kind of similar to AI Dev Gallery in that there's some various samples here for us to use and try out. All of these tabs off to the left show off the various WCR capabilities, but we're still focused on 𝗲𝗀𝗀𝗃, so we're going to be in the language model section. First thing I'm going to do is go ahead and create a model session, and we're good to go. Then we'll look in this text completion area. There's a couple of tabs up here with some different options, and we're actually going to be in the tab that is Generate Response with Options. So I'm going to go click on that. Here you can see that there are 8 total dropdowns, 4 for the input and 4 for the output across each of the 4 categories of harm: hate, sexual, violent, and self-harm. If we go into one of these dropdowns, we can see that there's 2 levels: medium, which is set at the default, and low, which is the alternative. 𝗲𝗀𝗀𝗃 has a built-in content moderation layer at the platform level. The API will filter out content classified as potentially harmful by default, but developers can configure sensitivity levels for both input and output. This system is designed and implemented similarly to the one provided by Azure AI Content Safety. The harm categories and the levels align with what can be found in the Azure AI Content Safety guidance. The medium level means that a medium level of harmful content is allowed, whereas the low refers to a lower amount of harmful content allowed. So, although it may seem a little bit counterintuitive, low is the more restrictive filter. So let's see how these interact in practice. Let's stick with our Minecraft example, and we can even turn up the intensity a bit. Instead of slay, I'm going to go with how to kill mobs in Minecraft. We still get a response here. So let's say we want this kind of output blocked from generating. I'm going to go to the Violent Content tab, and I'm going to increase the level of block from medium to low on output. And I'm going to go ahead and run this again. For the test app, the content will generate, then block once generation is done, but you can enable this block to occur dynamically as content generates. Great. And as you can see here, we have response blocked by policy, which means that the content filter has blocked the output response. So now I'm going to go ahead and I want to show you, maybe there's a reason why you wouldn't even want the input to go to the model at all. No generation even possible. So I'm going to go over to the input section now, and I'm going to increase the filter there from medium to low. And I'll go ahead and reset the output filter too. And let's try regenerating that. And immediately, you can see this one, prompt blocked by policy. Just like that, you can adjust the sensitivity across the harm categories to cater to your application. There's another option that's available to you as well with the API system. We can also use a system prompt to address and mitigate harms. So we're going to go ahead and flip over to the Generate Response with Context tab. 𝗲𝗀𝗀𝗃 also has an open system prompt for you to set as the developer. We often use the system prompt as an additional layer of mitigation to help cater and provide a safer response. I'll generate on the same prompt as before, but this time, let's come up with a system prompt. I'm going to try only respond in ways that promote self-defense. Do not encourage violence towards others. Perfect. There you go. A helpful response for gameplay that avoids potentially violent content. So as a developer, those are just a few of the tools at your fingertips. But, like we discussed earlier, technical interventions are only one piece of the puzzle. And, on top of that, we recognize that no technical intervention is infallible. There's always a chance for occasional errors, so we recommend implementing supplemental RAI tools and practices in addition to what the platform itself provides. In Windows, we found that there are many things outside of just technical interventions that build a responsible product, such as customer documentation, UI/UX design elements, clear feedback mechanisms, and appropriate ways to address issues as they arise. Let's take a look at some of these tools through a feature on device. Today, we're going to look at Click to Do. Click to Do is an AI-powered feature that can analyze your screen and suggest potential actions based on the content. Let's take a further look at this functionality, and we're going to stick with our Minecraft theme. I already have pulled up some information on mob spawning into this notepad page. We're going to experiment with Click to Do on that. I'm going to click Windows Q. It detects the text on my screen. I'm going to click on that, and it's going to pop up with some options. Click to Do will suggest the actions that I can take based on the content on my screen. There's a distinct section in this pop-up for Copilot actions, which are the AI-powered actions that you can take. For sake of simplicity, I'm going to go with Summarize. And we get a nice summary of mob spawning. In this pop-up, we also have a feedback button at the bottom where I can report issues. As a developer, you should consider having easy access to feedback mechanisms to help your customers report issues, as well as a plan to address any of these issues as they may arise. Let's talk a little bit more about the feature itself too. When the text is summarized, the response is pulled into a separate pop-up that is separate from the original text area. Users have the option to copy this text, then use it how they would like, make any edits, replace their original text, etc. But we are sure not to write over the user's initial text. Another best practice to consider is putting checkpoints for your users to validate the system output and make any edits they'd like before accepting the response. The last thing I'd like to show you in Click to Do is this pop-up menu at the top. Here I'm able to access the Learn More documentation, which details feature functionality, intended uses, privacy information, and responsible AI information. And in this responsible AI information, we even include model transparency notes so you can further understand what's powering your AI features. If you want to learn more about any of the tools that we discussed today, download some code to play around with, or read our public documentation, you can do so from these links. We are constantly improving and innovating in the name of customer trust, and we'd love to hear your thoughts and feedback. Please scan the QR code to take our brief survey and help us help you by sharing your perspectives, which will inform us as we create tools to solve for your AI needs. Here at Windows, we see responsible innovation as both business imperative, but also as a key differentiator for our customers. In the age of AI, it is more important than ever not only to meet, but to surpass customer expectations for trust, transparency, and control. And on top of that, it's the right thing for us to do. As you've seen today, responsible innovation entails more than just the technical details of the system. It requires taking a holistic look at the end-to-end process, starting early, and building with the customer's best interests top of mind. AI is rapidly expanding in scope and capabilities, and as this technology continues to evolve, so will we. Thanks for watching, and enjoy the rest of Build.